An important skill in algebra is knowing how to translate words into algebraic expressions and equations. Before we practice that skill, let's first make a distinction between what an algebraic expression and what an equation is. An algebraic expression is a mathematical phrase that consists of variables and or numerals, often with operation symbols. This would be something like x plus 5, or 7 times y, or 7y. An equation is a mathematical sentence that contains an equal sign as well. So this would be something like x plus 5 equals 13, or 7y equals 21. The distinction is primarily that one contains an equal sign and one does not. So let's practice translating first into algebraic expressions. Well, when we translate, we'll be looking at words, and each one of these words will have special meaning. Many of these words you're familiar with, but take a look at the table at the top of the screen and see if you know what each one of these words would stand for in terms of which operation you would need to use. I'll reveal the answers. We have our sum, difference, product, and quotient being adding, subtracting, multiplying, dividing. Times, twice would be 2 times. More than, less than. Per means division often. Of means multiplied, increase by, and decrease by. Of course, there are many more keywords than just these, but here's just some to start. So let's practice translating these 5 expressions. Half of a number. The number is what we don't know. We'll call that x. And half of it means that we would divide it by 2. There are other ways you could express this. You could write it as 1/2 times x, or you could call it x divided by 2 this way. Either way, it's half of that number x. 5 less than a number would be x minus 5. 3 more than twice a number. Twice a number would be 2 times x. And if we have 3 more than that, it'd be 2x plus 3. The quotient of a number in 7 means that we're dividing a number in 7. And lastly, the product of 2 numbers decreased by 4. Here, we have 2 numbers, and we don't know either of these numbers. So I'm going to multiply x and y together. So x times y, and then decrease that product by 4. Now notice the variable I chose to use was x in many of these cases, but you could use other variables as well. Y or a, b, any variable that you choose. Translating words into equations is very similar. The biggest distinction is the existence of an equal sign, and is a common word that's used to denote equals. So let's try 4 examples of translating words into equations. A number plus 54 is 79. When translating these words, I suggest that you try and go piece by piece within the sentence. A number, x, plus 54 is, which means equals, 79. Now, if we wanted to, we could solve this equation, which we won't do at this time. 20 equals 4 more than twice a number. Here's an example where I need to think about the whole thing together. Twice a number would be 2 times n, and then 4 more than that would be plus 4. Of course, since it's addition, you could have called this 20 equals 4 plus 2n, and that would also be acceptable. The difference of 10 and half of a number is 30. So the difference means we're going to be subtracting. The two things we'll be subtracting is 10 and half of a number. So my number I'll call x, and half of it would be x divided by 2. So the difference between 10 and x divided by 2 is 30. Finally, the last example, Jimmy was 14 years less than Sally's age. Sally was 51. What was Jimmy's age? Here, this is a bit more complicated because we have the words embedded in a couple sentences. Let's look at the first one. Jimmy was, well, what we're trying to figure out was exactly what was Jimmy's age. So that's what we don't know. So Jimmy was means x equals 14 years less than Sally's age. Well, we know Sally's age was 51. And if Jimmy was 14 years less than that, that means that x must be 51 minus 14. And again, if we wanted to solve it, we could find exactly what Jimmy's age was. In this case, it would be 37. So it's important to pull out the key words and put the operations and numbers in the right places, because minor mistakes in the order in which you translate these could make a big difference in the way you solve them.